I renamed this function to handle boundaries. I think it's more appropriate. We are handling the boundaries, not just checking them. We're handling them. Let me run this. I want to point out a flaw with our approach. Okay, see the top of the ship? Watch this top half of the arrow. Watch that most of the ship, or at least half of it, exits the screen before we actually bounce back in. And that's because we are using the ship position to test against the edge of the frame here, right? And the ship position is the dead center. Remember when we were making our ship, we went off the center of the ship as the ship moves. Anyway, and our three vertices made up the, or three vectors made up the vertices of the ship. And then also, if a ship hits the side of something, I don't know, maybe this is some enclosed structure, I'd expect the ship to explode or crumble up or something like that. Bouncing, not too realistic, but it's a game. Who cares? We might be used to that. Alright, we're just doing one type of approach. Now, I'm not going to fix the problem, but I will definitely point out to you that if you want to, you could test to see if any part of the ship is off the screen. All right, that'd be a good exercise. If any part of the ship is off the screen, then bounce the ship. And then furthermore, we probably will eventually get around to doing this. If I hit, let me see if I can get this. I'm going to restart here. Let me just get the ship moving upwards. Say I turn the ship sideways here. This back corner of the ship is going to hit the edge of the screen. I'd kind of expect this thing. Let me do it one more time. I'm going to see if I can fake this with rotations here. Okay, get that back left corner up. And then I would expect if I hit the side of the screen, the ship would kind of boom. You know, if I, just like if you dropped a pencil on the floor. Okay, we'll do, say the edge of this is a pencil, and the edge of the pencil hits the floor, and it would boom, boom. Well, not like that, but the pencil would fall flat on the floor. We're going to eventually do some physics. We're going to do some cool physics, and when we get that far, we'll actually look at how to make the ship rotate and pivot off whichever edge comes into contact with anything. It'll actually be quite cool and quite fun. And if you've ever played Angry Birds, you know that there's tons of physics going on in there. But it's actually not that difficult to have the things kind of, the blocks kind of crash and crumble and that sort of thing. We'll get there eventually. We got graphics and other things to get to. All right, I'm rambling on. Let's do wraparound. If the ship exits the edge of the screen, then we just need to position it at the other edge. It actually sounds like it would be pretty straightforward. I'm going to copy this code we made in the last video. Look at all these ones here. All right, that's kind of bugging me. Const. Did we make an int unsigned uint? I think we did. Const uint edge position gets 1, and even though, you know, one is technically not usually seen as a magic number, but I really think it's kind of magic in this case because it's really the position of my ship. So I'm going to actually put edge position all over in here, like so, just so I can feel better about it, and just make sure. You know, why did I do unsigned? That's not unsigned. It actually is an int. Int edge position unsigned. Remember, the boundaries go from -1 to 1. So if I go unsigned, that doesn't make any sense. Thank you, compiler, for catching that. Looks like it's still working. Okay, let's grab this code and paste it right here and format a little so. And I'm just going to comment this out for now. This is our bouncing code, so to say. If we hit the edge position, then we basically want to move the ship to the other edge. Okay, in fact, maybe copying and pasting that code isn't going to help for the learning experience. If ship position dot y is greater than 1, then ship position dot y gets a -1. Let's move it down to the bottom of the window. If we go past the top of the window, let's move it to the bottom of the window. Let's see how well this logic works. Up arrow, watch the ship, should wrap around. Boom. That's slightly disturbing. Okay, in fact, if I can get the ship going even slower, let's get it real slow. Oops. Let me just, nice and slow. Slow ship. Let's get to the edge. Oh, it's going to take a while. Watch it. It'll just pop, disappear. Okay, it's not as disturbing if you get moving faster. You kind of can't notice. But if we're moving slower, it's like the ship pops and reappears somewhere else. And So we could certainly make up for that, and the way we would make up for that is saying, hey, once the ship has gone completely off the screen, then wrap it around down to the bottom. Okay, I'm not going to do that, but I'll leave that as an exercise for you. If you're interested in it, you could certainly say, do some logic, figure out how do we tell how far the ship is off the screen? How do we tell when the ship is completely off the screen? Then wrap it around. Let's not do this. Watch, this will pop real bad. Pop! Like so. I'm going to leave that as an exercise for you, but here we go. Ship position Y is greater than 1, then do that. We need to do the opposite direction, so it's not as easy as checking both and then just inverting. We actually have to handle the edges individually. So if ship position Y is less than -1, then make 1 there. And oh, look at me using these 1s instead of edge position. I just made that edge position constant, but there you go. That's looking good. Let's go back down to the bottom, see what happens. Yep, so far so good. And then let's do the let's say edge position. Edge position, like so. Control C, Control V, Control V, Control V. Love copy and paste programming. It's so dangerous. You've seen me screw that up before. I'm going to change all these to X's. And we should be good for the entire boundary set. Let's look here. Let's get this ship going. And X, Y. See, if I move fast enough, you can't really tell the pop, but that kind of feels asteroids-ish, doesn't it? It's feeling kind of good. So there you go. That's wrapping. Oh, that's going to make me dizzy. I'm going to turn that off. The next thing I want to do, first of all, this is terrible how I've just commented out this code. I'm actually going to put a comment out here. This is, what is this? This is bouncing. And this is wrapping. Wrapping. And then the next thing I want to do is have the ship. I'm going to make an arbitrary boundary in here. We're going to make it probably a diamond. That's probably what I'll do. I'll make a diamond here. Okay, and when the ship hits the diamond, if I hit the diamond roughly straight on, I should just bounce straight back. But if the ship hits the diamond like this, then it should bounce something like that. And that's the logic I want to do in the next videos. But what I'm going to do before that is just get rid of I think we're done with this. This is good learning code for you. I'm going to get rid of it and prep ourselves to handle the arbitrary boundary, which is way more educational, way more interesting, and way more fun once you get it working.